This is a demo to help you get started with the Nestle filter. They talk about in a paper using the radiation planning system to get the regions of interest. In our case, we'll use whatever we have. We have two ways of making the regions. This manual drawing, or using the auto segmentation in the Nifty. We'll start off with the manual, and we'll start off with the simple system where we specify the lower threshold and the upper threshold, and all pixels between those two limits are counted. So when it finds the SUV max, for example, it finds 20. Not that the SUV max is really 20, because you can see this black region is not being counted, but we've defined it that way. In going on to the percent and to the Nestle, this upper SUV will be ignored. So we'll go first to the percent, 41%. 41%. Click, and you'll see this drops, and this will drop. Okay, it's gone down to 53. But the SUV max is the actual SUV max. It's no longer limited by this upper limit. This upper limit is simply ignored, both in the percent and in Nestle. Okay, now we move on to the Nestle case. Instead of 41%, we'll use 0.3, which is the beta, and N for Nestle. That's the sign we're using, Nestle. And what I want to show, first of all, the volume will go up, but the SUV max will not change. Okay? It's nearly double. The number of points here is greater. Now, how's the calculation actually done? The difference between the percent and the Nestle is the percent uses the SUV max as is. The Nestle says, no, we can do better than that. Let's take the SUV max and take a mean of all points, which are 70% of that value. So the 70% mean of this particular SUV max, instead of 45, is 35. And there's another difference with the Nestle. The Nestle has a background, which is added to the 0.3 times the 35 SUV. And that's what determines the cutoff value. So it starts off with a default value of 2.0, but I can choose the background wherever I think is a logical place to choose. Normally it's in the filter, in the liver. But in this case the liver is very hot, so I obviously don't want to choose the background in the liver. I'll take a random point, which it looks like a reasonable background, and I'll click on that. And I'll hit this background button, and you'll see this number will change. Okay, it's dropped down to 1.3, and the volume has increased because I'm using a lower background. I've switched the case from the gallium study to a brown fat study. And I've switched from using a manual region to using the auto segmentation in this Nifty. And again, we'll start with a 2.5 to 20. We'll show all. You can see all these things are being picked up. But instead of showing all, I want to concentrate on one particular region so we can look at the SUV max. Here the SUV max in this region is 15, and the volume for the simple case is 43. Okay, so the next thing to do is go over to 41%. 41%. When I hit the refresh, this will decrease. Here the SUV max is not going to change because the 20 is no longer limiting it. Okay, the value has gone down. And again, it's found the SUV max is 15, used a single point, took 41% of this 15, and that defines the threshold. So the next thing to do is go to the Nestle case. Instead of percent, to use again 0.3, which is the beta value, and N for Nestle. And again, when I hit the refresh, the volume is going to change. The SUV max is not going to change, and this will be replaced, the peak, by the SUV Nestle value. Okay? This is the SUV max, 15. This is the 70% mean within that, around that 15%, and it gives me a 12.12. Okay, again, the background is back to its default of 2.0. But now I want to go and put a liver value in. Remember, the volume is 22.5, and if I choose a different value, this number will change. Okay, it doesn't refresh. Didn't make any difference, presumably because the number of points is significantly smaller. But in general, you have these parameters. You can play with the background, you can play with the beta value, and you can see how different things affect to choose your best your best choice. So this is basically what I wanted to show.